Welcome to the Cala Builders podcast. If you buy an empty lot in Los Angeles today, the shovel won't hit the dirt for almost a year.
Yeah, it's wild to think about.
It really is. I mean, you'll actually spend more time arguing about the exact mathematical airflow of your air conditioning ducts than you will pouring the concrete foundation.
It is a totally counterintuitive reality. I mean, the modern custom home building process in Southern California is, well, it's basically an exercise in complex logistics.
Right, and rigorous bureaucracy.
Exactly. Long before anyone even picks up a hammer.
Which is why, for today's deep dive, we are pulling back the curtain on a timeline that catches almost everyone off guard.
Oh, completely off guard. People are always shocked.
Yeah. So we're looking at a detailed industry guide written in June of 2026 by Shaheen Eterafi. And Shaheen is the founder of Cala Builders, which is a full-service design-build general contractor.
And they have a massive footprint, right?
They do, yeah. They handle everything from Pasadena across the San Fernando Valley, all the way out to Santa Monica.
Which is a huge variety of terrain to cover. And the background of our source here is actually highly relevant. I mean, Shaheen is 33, but he brings over a decade of hands-on experience across basically every major trade.
Right. He didn't just, study construction management in a classroom.
No, not at all. He has physically built these structures.
And he started Cala Builders to solve this really specific, really pervasive problem in the LA market because homeowners were getting handed off to these project managers
who had never held a tool in their lives.
Exactly, never held a tool. And they were handing out incredibly vague, highly unrealistic timelines, basically just to win a bid.
Which just sets everyone up for failure.
It does. So our mission today is to walk you through the absolute reality of building a custom home in Los Angeles. We're talking about a full 18 to 36 month timeline.
It's a journey.
It really is. We're going to break down the hidden delays, the physical constraints of the materials, and how a unified design-build approach tackles this completely chaotic environment.
So it's good.
Let's start with the time frame itself, which is, well, it's heavily front-loaded with paperwork.
Yeah, the pre-construction phase. I mean, most people operate under the assumption that building a house begins with heavy machinery rolling onto the lot.
Right, the fun part.
Exactly, the visual part. But the reality is that the paperwork and the engineering, they take almost as long as the physical construction itself.
And the numbers in the guide break it down so clearly. Like if you're building a standard 2,500 to 3,500 square foot home on a relatively flat lot,
which is a pretty standard project.
Yeah, standard project. You are looking at 18 to 21 months minimum.
Minimum.
Right. And if you introduce complexity, like, say, hillside construction in the Hollywood Hills or building in a coastal zone, that timeline immediately stretches.
Oh, massively. You're suddenly looking at 24 to 36 months.
2 to 3 years. And pre-construction alone consumes 6 to 12 months of that total time.
It's a huge chunk. And if we break down what happens in those 6 to 12 months, it becomes pretty clear why it takes so long.
Yeah, walk us through that.
So the initial design phase takes 8 to 16 weeks because you need the architectural floor plans to dictate the space, obviously.
The layout.
Right. But you also need a structural engineer to run mandatory seismic calculations.
Which is totally non-negotiable in California.
Oh, absolutely non-negotiable.
Right.
And on top of that, you need a Title 24 energy consultant. They have to produce a compliance report covering literally everything from your wall insulation to your HVAC system and solar integration.
Okay, wait, here's where I have to pause. Because if I'm building a house, I'd assume the structural engineer doing the earthquake math and the energy consultant looking at the solar panels and the HVAC, I'd assume they're operating completely independently.
Most people do.
Like, why do they even need to coordinate during the design phase? They seem like totally different disciplines.
They seem different, but they're fighting for the exact same physical space in the framing of the house.
Oh, I see.
Yeah, think about a single 10-foot stretch of wall or ceiling cavity. Let's say the architect designs a beautiful open-concept living room.
Sounds great.
Right, but then the structural engineer looks at that wide-open span and says, well, to survive an earthquake, we need a massive, continuous load-bearing steel beam right here.
Okay, makes sense.
But then the Title 24 energy consultant looks at those exact same plans and says, well, to achieve the required energy efficiency rating, we need to route a large, heavily insulated HVAC duct straight through that exact same ceiling space.
Oh, wow. So they're literally colliding on paper.
Exactly. If the architect, structural engineer, and energy consultant aren't actively communicating, you end up with a duct occupying the same physical space as a steel beam on the blueprints.
And I imagine the city isn't going to just, let you figure that out on the fly during construction.
Not at all. Because once you have these documents, you submit them to the Los Angeles Department of Building and Safety, the LADBS.
Right.
You submit it for their plan check. And this initial review takes 4 to 6 months.
4 to 6 months just for the review. I mean, it's essentially like a highly rigorous academic peer review, but for the building's foundational math.
That's a perfect way to describe it. If you submit conflicting plans where the structural elements and the energy elements overlap impossibly, the city catches it.
And what happens then?
They reject the plans, and you are hit with a 6 to 12-week correction penalty.
12 weeks.
Yeah, you have to redesign, re-engineer, and wait in line all over again.
It's a massive time penalty just because the team wasn't aligned in the first place. I mean, that really highlights why the guide stresses not rushing those initial floor plans.
Precisely. And this is where the design-build model really shines, by having the architect, the engineers, and the construction team working within a unified firm.
Like Cala builders.
Right. They coordinate these overlapping requirements internally. They catch the conflict between the steel beam and the HVAC duct in, week 3 of the design phase.
Rather than discovering it in month 5 during the city's plan check.
Exactly. It saves months of wasted time.
So, okay, you survived the city's academic peer review, you finally have your approved permits in hand, and you think you're clear to just start throwing up wood framing.
You'd think so.
But immediately, the process hits a literal roadblock with the dirt itself.
Yeah, breaking ground in Los Angeles introduces an entirely new set of physical variables. And it really starts with the immense geological diversity of the area.
Right, because LA is huge.
It is. And the soil conditions change drastically depending on what neighborhood you are in. That completely dictates the entire foundation strategy.
The guide maps this out perfectly, because if you are building in Santa Monica, you might be dealing with highly sandy coastal soils.
Yeah, very loose dirt.
Which means you might have to drill deep friction piles just to stabilize the foundation. But then if you are in the San Fernando Valley, you're likely dealing with expansive clay soils.
And if you are up in the hillside zones, you are basically excavating into solid bedrock.
Right. So let's look closer at the expansive clay in the valley, because I think it's a great example of how geology dictates the timeline.
Oh, absolutely. Expansive clay acts like a massive geological sponge.
A sponge?
Yeah, when it rains, the clay absorbs water and physically expands. It pushes upward with immense force. And then in the dry summer, it shrinks and cracks.
So if you just pour a standard concrete foundation on that soil?
The house will literally heave and crack apart over a few seasons.
Wow. That's terrifying.
It is. You have to engineer a specialized foundation, usually something like a post-tension slab filled with steel cables that can handle that tension.
Which obviously takes more time.
Way more time. More excavation and highly specific site preparation.
And once you actually dig the trenches and finally pour that concrete foundation, the wait still isn't over. I mean, you'd think the framing crews would be out there the very next morning.
Well, homeowners always think that.
Right. But the guide points out that standard concrete requires a non-negotiable 28-day cure time.
Yep, 28 days.
That's a full month where it looks to you, the homeowner, like absolutely nothing is happening on the lot.
This is a classic point of friction.
Yeah.
Homeowners drive by, they see a solid gray slab, and they assume it's ready to go.
Yeah, they wonder why their contractor's just slacking off.
Exactly.
I mean, we're so conditioned by modern reality TV shows where an entire house is built over a long weekend. But, nature and chemistry do not care about a television schedule.
They really don't.
So what is actually happening inside that concrete during those 28 days?
It's an incredible chemical process called hydration. See, concrete doesn't just dry out like a wet towel left in the sun.
Okay, so it's not evaporation.
No, it's less like drying and more like knitting a dense microscopic fabric. The compounds in the cement are forming complex chemical bonds with the water molecules.
Oh, fascinating.
Yeah, they're growing millions of tiny interlocking crystals. And those crystals physically stitch themselves together over time. It takes exactly 28 days for that microscopic fabric to knit tightly enough to reach its full structural design strength.
Okay, but what if a builder caves to pressure from an impatient homeowner and tries to just start building the house on, say, day 14?
Well, if you throw tons of heavy wooden framing, roofing materials, and second-story loads onto that foundation, before the crystallization is complete.
Before the fabric is knitted.
Right. You are essentially ripping the fabric before the stitches are tight. You induce microscopic fractures deep within the core of the concrete.
That sounds bad.
It's terrible.
Eh.
In a high-risk seismic zone like Los Angeles, compromising the integrity of your foundation means the entire structure is fundamentally unsafe. It will fail when an earthquake hits.
So it's a permanent structural flaw introduced just to save a couple of weeks.
Exactly. And this is where Shaheen's hands-on background really shows its value.
Because he actually knows the chemistry.
Yes. Because he intimately understands the material science, because he has physically been the one pouring the concrete, he gives clients straight answers up front.
He doesn't sugarcoat it.
No, he tells them, look, your lot is going to sit empty for a month, and here is the exact chemical reason why.
That transparency manages expectations so beautifully.
It really does. And once the foundation is properly cured and passes the mandatory LADBS foundation inspection, you can finally move to the phase that homeowners actually look forward to the most.
The framing.
The framing.
The house actually starts looking like a house. The wooden skeleton goes up, and the guide estimates this framing phase takes about 4 to 10 weeks, depending on the square footage.
Right.
But the moment that beautiful frame is finished, the project dives right back into a highly bureaucratic, invisible bottleneck.
The rough-ins.
The rough-ins.
Yeah, the rough-ins are where the house basically gets its nervous system. You are threading the plumbing pipes, the electrical wiring, the HVAC ducts, and all the low-voltage systems for smart home technology through those wooden studs.
And this isn't just about the physical labor of running wires, is it?
No, it's about how these trades physically interact within the wall cavities. Think about a single wall stud bay. The plumber needs to run a 4-inch drain pipe down. The HVAC installer needs to route an 8-inch rigid air duct up, and the electrician needs to thread thick bundles of wire through whatever remaining space there is.
Wow. So if they aren't sequenced perfectly,
they end up physically blocking each other's work. It becomes a literal traffic jam inside the walls.
And the complication in Los Angeles is that each of these trades requires a separate LADBS inspection before the wall can be closed up with drywall.
Yes. You can't just have an inspector come out once at the end and look at everything.
Right.
The framing, the plumbing, the mechanical, and the electrical are all distinct inspections.
And the guide points out that booking an inspection with the city adds 1 to 5 business days per trade.
It adds up so fast.
It really does. This is where the sheer size of the house acts as a massive timeline multiplier. I mean, a standard 2,500 square foot home takes about 9 to 12 months of active build time. But a 5,000 square foot home takes 16 to 24 months of active building. When I read this, I immediately wondered how a contractor prevents this from spiraling into total chaos. The guide calls it stacking delays, right?
Stacking delays, exactly. They occur when one minor hiccup causes a massive domino effect.
Give me an example of that.
Okay, so say the plumber gets stuck on another job and finishes his work 2 days late. Well, the electrician can't run their wires because the pipes aren't in place yet.
Makes sense.
Then the city inspector arrives for the plumbing inspection, sees it isn't finished, and fails the site. Now you have to rebook the inspector, which takes another 4 days.
Oh, man.
And that pushes the electrician into next week. By the time you untangle the schedule, you've lost 3 weeks of build time to a 2-day plumbing delay.
The coordination required to avoid that is just immense.
It really is the defining value of an experienced general contractor. It's about conducting the orchestra.
That's a great way to put it.
And because Shaheen has over a decade of local LA experience, he relies on deeply established relationships with his subcontractors.
They aren't just random names pulled from a bidding app.
Exactly. He knows precisely how long his framing crew takes and how fast his plumbers work. So he can confidently book the electrical rough-in and the city inspector weeks in advance. The timing is threaded perfectly.
So the relationships are quite literally keeping the project on schedule.
Yeah.
Okay, so let's say the contractor navigates that maze perfectly. The rough-ins are done, the inspections are passed, and you are ready to close the walls and start the finishes.
The exciting part.
Right, you're thinking about drywall, paint, lighting, fixtures. But before a single sheet of drywall can go up, the guide highlights a uniquely Californian hurdle that stops the whole project in its tracks if you aren't prepared.
The Title 24 HERS inspection. This is perhaps one of the most critical choke points in modern California construction.
We touched on Title 24 earlier regarding the design plans, but HERS stands for the Home Energy Rating System, right?
That's right.
And it's not the city doing this inspection. It's a specialized third-party inspector who comes to the site to physically verify the energy efficiency of the work you just did inside the walls.
Yeah. They are looking at the insulation quality, but more importantly, they are rigorously testing the air sealing and duct leakage.
And the way they test this is just fascinating to me. They use what's called a blower door test.
It's a very intense test.
They physically seal your front door with a specialized frame containing a massive fan.
Yeah.
And they turn the fan on to depressurize the entire house. They're essentially sucking the air out to see how much outside air leaks in through the gaps in your framing, windows, and ductwork.
And they use highly sensitive pressure sensors to measure the exact volume of leakage. If your home breathes too much, or if your HVAC ducts are leaking air into the attic, you fail the test.
And if you fail the HERS test,
you are legally prohibited from installing drywall.
Wow, so everything stops.
Everything. You have to go back, hunt down the microscopic air leaks, seal them with mastic or specialized foam, and pay for the inspector to run the depressurization test all over again.
That sounds like a nightmare.
It is. All the subsequent trades, the drywallers, the painters, the cabinet installers, they're all placed on an indefinite hold.
And even assuming you pass the blower door test on the first try, you are walking straight into another massive timeline trap. Material lead times.
Oh, the supply chain. The physical procurement of finishes and fixtures requires incredible foresight.
The guide lays out the stark reality of supply chains here. Custom, energy-efficient windows can take 12 to 16 weeks to arrive from the date of the order.
That's 3 to 4 months.
Right. Custom cabinetry requires 6 to 12 weeks. High-end European lighting fixtures routinely take 12 to 20 weeks.
And even the exterior finishes require patience. I mean, the standard 3-coat stucco systems used across LA, they require specific curing times between each individual coat to prevent cracking.
And human nature usually works against the timeline here, doesn't it?
Constantly. Homeowners are highly visual creatures. They want to stand inside the physical framed space of their new kitchen to visualize the flow before they commit to a specific cabinet wood grain or, an imported chandelier.
Which is such an understandable impulse. I'd want to do that. But reading this timeline, I realize it's a catastrophic mistake.
It really is.
It's like planning a massive wedding but ordering the custom dress a week before the ceremony. If you wait until the room is framed to order your Italian lighting fixtures, you are pausing the entire build.
Yeah, the house just sits there fully framed while you wait 5 months for a cargo ship to cross the ocean.
And you're paying interest on a massive construction loan while the site sits completely idle.
This is exactly why a design-build firm fundamentally shifts the procurement timeline. The crucial insight from Cala builders is that those 12 to 20-week lead time items must be selected and ordered during the pre-construction phase.
Oh, right. While the city is still doing the architectural plan check.
Exactly. Seamless project management means anticipating the end of the project before you even begin.
That makes total sense.
By the time you pass that Title 24 HERS inspection and the drywall goes up, your custom windows and kitchen cabinets shouldn't just be ordered. They should be sitting in a local, climate-controlled warehouse, ready for installation the very next day.
It's a complete paradigm shift in how you plan. You essentially have to make decisions about the doorknobs while you're still looking at a dirt lot.
Pretty much.
Okay, so we've walked through this immense logistical labyrinth. The soil mechanics, the 28 days of concrete crystallization, the physical clashes inside the wall cavities, the blower door pressure tests, and the international supply chains.
It's a lot.
It is a lot. Now we have to address the ultimate reality check. The finances. What does it actually cost to pull this off?
Yeah, the financial expectations of homeowners often clash pretty harshly with the physical realities of the Los Angeles market.
The guide addresses a question straight from the Cala Builders blog. The question is $300,000 enough to build a house in LA?
And the answer is a flat, definitive no.
Yeah, not even close. We have to look at the per square foot metrics in 2026. New home construction is running between $400 and $1,200 per square foot.
It's a massive range.
So let's anchor that to a realistic scenario. Let's take a standard 2,500 square foot home, the kind of house you see in a typical family neighborhood. You might look at your savings and think, okay, $500,000 should easily cover it.
But when you run the math, you realize the baseline construction costs alone for that home will range from $1 million to well over $2 million.
Wow.
And it's crucial to understand that those numbers don't even include the cost of purchasing the land, the architectural design fees, or the city permits.
Which are huge expenses on their own. Even a tiny, modest 800 square foot home, essentially an accessory dwelling unit or ADU, costs between $320,000 to nearly $1 million just to construct.
Right.
So a realistic budget for a standard custom home today starts firmly at $1 million, and it typically lands in the $1.5 to $3 million range.
And that kind of sticker shock is incredibly common for people just entering the market. They see the final number and immediately assume they're being overcharged.
But when you step back and view the total picture we've just painted, the price tag actually starts to make complete logical sense.
It really does.
Because you are paying for heavy steel reinforcements engineered to survive earthquakes. You are paying for highly specialized third-party energy consultants to depressurize your house with giant fans to meet stringent environmental laws. You are paying for the month-long wait for the microscopic fabric of the concrete to knit together safely. And you are paying for up to 3 years of highly skilled, intricately coordinated labor to weave plumbing and ductwork through a wooden skeleton without failing a single inspection.
Exactly. You realize very quickly that you aren't just paying for the raw materials of wood, nails, and drywall.
No.
You are paying for the deep expertise required to safely navigate a geographically volatile and intensely regulated environment. Choosing a fully licensed, bonded, and insured firm like Cala Builders is basically about risk mitigation.
Right.
When you are making a multi-million-dollar investment, a unified team that knows exactly how to sequence a blower door test and knows to order custom windows 6 months in advance, well, that protects your investment. You are essentially paying for certainty in an industry defined by variables.
That is the perfect way to frame it. Does understanding the timeline actually help homeowners stomach that budget?
Oh, definitely.
Yeah.
Once they see the invisible work, they understand the value.
I can see that. Let's recap this massive journey for you, the listener. We set out to answer how long it actually takes to build a custom home in Los Angeles, and we discovered it is a 1.5 to 3 year marathon.
It truly is.
We learned that the invisible pre-construction planning, the engineering, the energy modeling, the city bureaucracy is just as vital as the physical labor. The traditional method of hiring an architect, finding a disconnected contractor, and hoping they figure out the wall cavity space on the fly, it's a recipe for stacking delays and cost overruns.
The total disaster waiting to happen.
Right. So the unified design-build approach isn't just a convenience, it is the ultimate strategy for surviving the complexity of modern city building codes.
And looking at the sheer depth of these regulations raises a pretty profound question about the future of housing.
Oh, like what?
Well, if building a home today in Los Angeles requires such intense energy efficiency testing, like those Title 24 HERS inspections tracking every microscopic air leak and such rigorous structural engineering, how will the very definition of a luxury home evolve over the next 50 years?
That's a great question.
Right. Because we've traditionally defined luxury by massive square footage, imported marble, and excessive space.
Yeah, huge mansions.
But as environmental regulations get tighter and the power grid becomes more strained, will true luxury eventually shift? Will the ultimate status symbol no longer be the sheer size of the home, but rather a home's complete, hyper-efficient independence from the city's power and water grids?
Wow.
Will luxury simply mean absolute self-reliance?
That is a fascinating thought to leave on. A house transformed from a drain on the city's resources into a hyper-efficient fortress of independence. Thank you so much for joining us on this deep dive.
Thanks for having me.
And to you listening, the next time you are driving past an active construction site in Los Angeles, or you find yourself staring at an empty flat lot wondering what could be, you're going to see it completely differently. You'll know exactly what invisible gears, chemical reactions, and mathematical calculations are churning just beneath the surface. Until next time.